Hello, hello. Today is the 1st of July. And we are still making cast the programming language. All right, I was trying to do something stream, and I was difficult. So what I was trying to do is I was trying to introduce the context system immediately into the types. So what's the difficult part? The difficult part is the inference of that stuff. Oh, Ogma, hello, lazy.
0008.
How are you guys doing? Okay, so the idea is that the things over here, I'm making a function that uses print. So the fact that it uses print should be denoted in its type signature. So previously we would write, let's see, what is the full signature of a function? We have argument and we have the body of the function, right? With a fat arrow like this. We can specify the type of the argument. And the context is basically a secret argument to the function, kind of. So we were saying something like this, with some context, you know. We can also try to specify the result type, like that. Returns unit. First of all, is this good syntax? If we don't like in your normal programming language, I feel like it's a little bit weird. You have like this arrow and this arrow. This is specifying the type of the return, and this is actually like doing the return. Maybe it's fine. Or like it's less weird if we have a function keyword and the curly bracket, because then we're more used to it. But maybe it's fine if we just do it with an arrow. Yeah, so yeah. And then so what's the type of a function? The type of the function is argument into return type, you know? Or just like, I don't know, a into b, right? Whatever. This is a function that takes a as argument and returns b. But the functions are also supposed to have the contexts. So we say a with some context c, returning b. We can make this so like the syntax of this is weird. We need to come up with where exactly it's being specified. Different languages do it differently. Sometimes we can say that we return b, but we can also do c, for example, right? What is an example of this? Like an example of what we can do is we can print, for example, right? We can have a function that takes a, returns b, but if the function can print inside, we can do that. Or we can say a with print into b. So we, in order to even start, I think this makes a little bit more sense, because we cannot get because this is like a hidden argument, so it should be in the argument position. the capability of printing is like a secret argument to the function. We can also say a into b with print. I mean, this is just a keyword choice. I feel like with is better than can, because then we can not only do the verbs but other things too, and then we can also do the as a symbol for it. So a slash, maybe a backslash, because normal slash is division, a slash print into b. Maybe this is pretty short and good. So the other languages that do that, I call them contexts. This is for effect systems. So language like Flix, for example, the way they do it is they have a function main that returns a unit and can do IO. Hello, Nerdcell. I'm discussing the syntax of the context system. I think I should change it. Previously, it was function A into B with contexts. I think we should instead say A with contexts into B. Why? I don't know. Because I'm redoing everything from scratch. We can question everything. So first of all, the reason why it's in the... So it is supposed to be in the argument position. Because context is like a hidden argument. So why is it in the end, after the return, you know? It should be in the argument, right? Because it is an argument. Why is this thing in the return? Well, I know why. It's because usually in your languages with effect systems, it's what a function can do. So it returns B and it can do something. You know? But technically, it's like a hidden argument, so it should be in argument position. And then instead of a with keyword, I think the backslash works fine. And then we also want to be able to specify the function. So if I say that to specify the function shortly, we just say, you know, argument into body, right? And I want to be able to specify the type of the function at the same time. So is it okay if we do x context into result is body? So it's literally the same syntax, but we add the fat arrow to it to say that it's not a function type, but a function like expression. It looks like a set difference or lambda. Oh, right, backslash. I was actually thinking, wait, hold on. I was actually thinking, wait, let's then go from the beginning. Should we have argument into body, or should we have backslash argument into body? Because then, yes, then we are not going to use the backslash for this. But I don't know if there is a reason for that. Here we go again. I don't think we should, though. I think we should not. I think this is simpler. So this is the full syntax, I think. So we can have a argument of some argument type with a context. We return a result. And then we have the body like this. Or do we want the function keyword? What about body argument into result? No, I mean, I think you can do body. You can specify the result after the body by doing this result instead of having this specified over here, for sure. Yes. I just type ascribing the expression, which is the body. But I don't know. Shouldn't you have full type inference? I do, but sometimes you want to specify the function arguments. the function thinks. I mean, on the other hand, we can always just say that, like, since this function, if I want to specify its type, we'll probably assign it to a variable f, right? And then we have argument into body, but then I specify the type over here, you know, we specify it over here, a in with context into b, right? Like that, and then we say equals. But that means that I don't like that we like kind of repeat the argument into places. By the way, I have a question. So your parser is extensible. The actual syntax of the language can be part of the standard library. Yes, that's how it was done before. I have not done it in the new rewrite, but it was already done like that in the old version. I'll get to it at some point. Like, for it to be properly part of the standard library, we need like a couple of other features. But yeah, we have the here's the old version, and we just have standard library, and here's the syntax, right? So this is a syntax module, and then in the actual standard library, we say that syntax is I'm just importing the syntax like that. So we have syntax as a normal like cast code, and then we implement the syntax also like that in the standard library through the macros. Did I hard code yes syntax? I didn't hard code it, but well, I mean, it's partly hard coded right now. It is still correct cast syntax right now, but it's not done through the import system, I guess. Yeah. Right now we have this syntax defined over here. This is still correct cast syntax fully, but yeah, it's a little bit special right now. We are going to make it less special later. Okay, so yeah, and we are going to modify the syntax right now. Although I was doing something and I did not finish it. My stuff doesn't compile right now. Hold on. So anyway, why not argument with context into result? With like the only change is with keyword versus backslash. You don't like backslash? You like the keyword more? Sure. Sure, we can keep the with keyword. So the only change then is going to be the fact that it's going to be before the arrow rather than after the result now. Because I think that makes sense. That change should happen, right? Okay, so and what I was doing is I was doing the inference of the contexts. You know what? I'm going to stash this, and then we're going to come back to it after I introduce the syntax for it. One error. Oh, wait. What is this? Wait, it's a change. Didn't I just stash the change and I didn't stash it? Oh, because it's untracked file. Stash. Can I have a stash with untracked files too? Can we also place it after the fat arrow? Yeah, but that's what I'm saying. It doesn't make sense there, right? Does it? Like, once again, it's a hidden argument. And I mean, I mean, it's supposed to be a type of the function. It's not like after the fat arrow we specify the implementation of the function. So like there should be just implementation there. Before the fat arrow or like an equal sign or whatever, we have the type signature. So the context type belongs to the type signature. But whether it's after result or not, I think before the result and closer to the argument makes more sense. You'd stash u. There you go. Okay, let's first do the syntax. So once again, the full definition of a function is going to be an arrow like that. So yeah, a function with the type. Yes. Let's have a function type separately. A function type is just argument into result and also with. So you want the with keyword here. Space with context arrow result like that, right? And then the actual function is so we are going to have argument with context result and then fat arrow and then body. So yeah, the with context part should be optional. The arrow should be optional. And then we would be able to, yeah, so right now I need to have kind of like these things to be separate. You know what? What if we just work more on the syntax? I want to support in my syntax definition to have optional parts. You know? Yeah, how about that? We have a context. Into yeah, with context. Should be an optional one. So we just do something like we wrap this in parentheses and then we do a question mark. And then arrow into result. We also say that it's an optional one, right? So an optional result, an optional context. We can specify 1, 2, or neither. And then we don't have like the dedicated syntax without the context and without the argument. Okay. We might use the question marks in other places too then, if I do that. Okay, yeah, fine. Let's do the syntax work. Okay, so this means that AST has a rule inside. So a rule, yes, a rule. A rule has parts. So parts are these, and now we are going to have a grouped part. A grouped part, which is going to be a group where group is, this should be recursive, I think, and group, because group can contain other parts. Right. So group is a type which has parts, which is a part list. So this is the parts inside, and then the quantifier. Later we are going to have the quantifiers which are like star, so it can be repeated multiple times and other things. The question mark though is really easy. Quantifier, right? And then we will have we'll have type quantifier is quantifier should be optional, I think. Yeah, I think the quantifier should be optional. And then the quantifier for now, we'll have the only one, which is going to be optional. Which means that this group can be there or cannot be there. The group might also, we might also want to have a name to the group, similar to how we have bindings to have names. Yes, let's have names to name string option. So because of that, we can, so like this entire group, we can name it. I think that makes sense. So it's like the context part is this with underscore, and the result part is this with underscore. I don't know, is that good syntax with the equal sign to name it? If I don't name it, it should not be flattened though, because so like when I get this syntax into the compiler, we're going to basically have the 3 arguments, or I guess in this case 4 arguments: argument, context, result, and body. And the context is going, since this is a group, it's going to be basically its own, like context is going to have fields. So in this case, the context will have a single unnamed field inside, but we could have like multiple values inside too, I guess. That's why I want names here. Otherwise, it would be argument and then an unnamed field, which makes no sense. Yeah, I feel like, yeah, this is correct. That's what I want to do. Okay. Let's first start with parsing this stuff. So cast parser. We want to parse the rule. We want to start by parsing the rule, right? Or we want to collect the children actually first. Yeah, we want to collect the children. No. I don't know. There's multiple places. Collect the children means that if I have already parsed the syntax, now I need to store it in a data structure. So for each binding, oh wait, hold on, I still need bindings. Yeah. So like this still needs to have a binding. There should just be no priority kind. Yeah, it's not bindings, it's like names. Hold on. So the collect children should return a list of the things that I assign to names. Yes. So if I have so this should be not binding, this should be just a string option, I think. So in this case, if I have a binding, this should be binding name. So binding name has this value. Yes. So now we just have this, not a binding, we have name. Binding. Tuple add name. Okay, there we go. That's simpler. So now there are other parts, right? We have we must also try to do the group. Right? So what do we do with a group? With a group, we just say that this group has parts inside, so I'm going to collect. I'm going to keep collecting the parts over there. So when I collect the children, I have that, okay. So let me just try to explain a little bit. Let's say that we have a syntax, right? Let's say we have a syntax rule, something like, you know, well, literally the one that we just did, right? This one. Let me make it in a simpler way, written in a simpler way. So we have argument, and then context is with underscore. This one is optional, and then the result is arrow into underscore, question mark, and then arrow into body, right? So this is the syntax, right? So we can basically parse code like this, you know, argument with context into result body, right? That will work. But we can also parse just argument into result into body. We can also parse argument into body, and we can also parse argument with context into body, right? So like, because both of these parts are optional, we have 4 variants of the syntax basically, right? So when we parse this first one, we basically say that I have successfully collected argument, context, result, and body as inner expressions. These are keywords, the arrows, the width, and the effect arrow, but the values inside are these, right? So now I want to collect what I have parsed into this. Right? So what do I do? First, so like we do it part by part. We see that the first, I expected it to be a value, and we have a value argument, sure. Then we had a group, and the group is optional. So whether this value is a context or something else is unknown. Give me a second. All right, so yeah, we have this that has been parsed. Hello, Nigel. Nigel, I'm doing quantifiers, but the only quantifier that I'm doing is the question mark for now. I don't know, for some reason I decided to do that. So whether we go into this group and match this value with the context, or is this context actually is a result, dependent on whether or not we actually had the with keyword here. So actually the list of everything that we matched is argument with context, like, I mean, the entire thing, right? This entire thing, we have all of these different parts. We're working on the formatting issues, also documentation. Wait, are you making documentation for cast? Nice. Documenting the code or something else? I don't know. Documenting the CLI. A read mean source syntax. All right. Argument with context into result is body, right? So yeah, we should like match, which means that this actually is not enough. When I'm collecting the syntax, just the list of these values that I have done is not enough, because whether we go into the group or not depends if I have the keyword or not. So what I have is AST parts. AST part is either like comment value or keyword. So like this is what we know, yes. So we have parts, values. I feel like the values are no longer needed. So I collect the children of the parts. So this is the parts of the rules. Rule parts, and these are the parts that I have collected. You know? Let's just call this actually like parsed parts. A little more descriptive name. So a parsed part should be basically let me first see, like the parsed part, if the parsed part is a comment, then we just ignore it. If we have a value here, yeah, so parsed parts, okay, and then oh my god, this language, AST part list, and this is a syntax rule part list. Like if I have this type of description over here, why is this needed? I just don't get it. Whatever. So this should be AST part list. Yeah. Well, I mean, let's just get rid of this completely and say that the return type over here is specified over here. Like that. Okay, then. We can also have a keyword followed by a value. Right? So yeah, if I have a value and we have a value binding, then we just pattern match. Value must be matched with a value, right? Yeah. Over here, keyword, we're not going to have the keyword. We're going to only ignore, yeah, we're only going to ignore the white space now. So we're going to just match keywords with keywords, similarly to how we are matching values with values. We should be able to match keyword with a keyword. Expected keyword, parsed keyword. So parsed keyword is a token, expected keyword is a string. So we just say assert parsed keyword is raw expected keyword. So if not, then we panic. I mean, this is supposed to be collecting children is supposed to be when I already when I have already parsed it, right? And collect parsed parts, expected keyword this, got that, expected keyword, and then token print expected parsed keyword, something like that. Okay. And then we just say that we are going to ignore it and collect the children. Okay, then we have another. So we have keyword and value, value and keyword. Those should be just impossible, right? So if we have a value, value and keyword, then we say unreachable, matched value and keyword. If we have keyword and value, then we have a keyword and value. All right. And now we only have like this group. So if we have a group, then what we're going to try to do, we're going to try to collect the children. We're going to try to go on with the parsed parts. All right. Yes. So if I have a group, collect children should give me the list of ASTs given the names. Yes. But this is no longer the ASTs, right? Because we either have a value AST or we have a group now. It's a little weird. When I parse the syntax, we either have a value or we have a group. So this should be like AST field or something. So when I have the AST being parsed, we have or I guess not field, maybe like child. So like children are not always just ASTs. Sometimes they are groups. Children is child tuple. So I say that child is either an AST of AST or it's a group. Or it's a group of group. And technically children is already is a group, so this is a group. So group, because like the original parsed one is already a group, right? A group is just children. Is a child tuple. So we have not the children, we have the root. So the root group, something like that. Does that make sense? So, and every child can be either an inner group or like the leaf. So this forms a tree. That's why we call it a root. That makes sense. Print shape, root. Root children. Print child. Now we should have a function print child, which is formatter child unit is function fmt into function. If it's an AST, then we just print fmt AST. If we have a group of a group, then we print group, empty group. Always not necessary here. And we have print group. It's formatter group unit is function fmt children into tuple print fmt children using print child. So over here we say I just print the root using print group like that. Okay. It's going to be a big change here. The cast compiler. Oh, I'm already in the compiler. Right. I have a complex this. I'm trying to compile this complex root. Yeah, handler root. So handlers should be not handling the tuple, but they should be handling the AST groups, right? So all of that needs to be changed a little bit. I mean, I can always just say this, children. Kind of should work for all the current syntaxes. I should just assert that every child is not an inner group, but it is an actual inner AST. Right? So like over here, the children, unbound record. Oh my god. Okay, sure. We have this in a group. This is AST group. Thank you. So now here, function is AST child, but it should not be AST child. It should be an AST, right? So I want children into tuple map. Expect AST child expect AST. something like that is what I should add everywhere. So we should have a module child, and when we have a function expect AST, if we have AST, we have AST, and if we have a group, and we say fail expected AST get group. Hello, Brainoid. How are you doing? Please get cast to a state where you can submit something to D2Jam using cast. That's in September, right? We have 2 months. It's doable, but like I need to work on it. Maybe all of that time. If I didn't get to start the rewrite, it would be more likely. But yeah, here we are doing the rewrite. I'm improving those some things for sure. We're gonna cast as a language tag in the website. Yeah. Hold on. We're going to get there at some point. Collect children. Yeah, so now we are back to the collecting children. So if I have a group, right? What am I going to do here? We have the parts, the parsed parts, and we have the group. So I will try to go into the group, right? I will try to go into the group. I feel like the groups always must start with a keyword, by the way, so that I know immediately if the thing is a group or not. I feel like that is a must. Yeah, I feel like that is a must. So like here we have an option. We either go into a group or not. We're actually going to do it depending on the group quantifier, right? Right now we obviously have only the... No, we have optional quantifier. Sometimes there is no quantifier. Yeah. If there is no quantifier, then we should always go into the group. Right. So we should say something like let go in. We need to decide whether we're going into the group or not here. So if the quantifier is none, then go in is true. If the quantifier is some optional, then it's a maybe. So if it's an optional one, then how do we decide if we go into the group or not? The decision is if our parsed parts start with the keyword that is the first keyword in the group. So over here I match once again parsed parts and group parts. Let me see this here. Let first keyword is match group parts with anything else, then we fail. Optional groups expect should have keyword as first part. I feel like that's a must. Maybe. And then if we have keyword, then that's my keyword. Now if I know the first keyword, we're going to match the parsed parts. And if the parsed parts is... I have already skipped the comments, right? Right. So if it is a keyword, keyword. So this should be not first keyword, this should be like expected keyword. If it's a keyword, then if it's a keyword, when keyword is raw expected keyword, only then we are saying true. In any other case, we say false. So now we know if I should go into the group or not. Now that I know if that I should go into the group or not, and if I do go in, well, I mean, yes, if, yeah, we're going to now match, go in with, if I don't go in, so it falls, in this case, we just skip the group, right? So go in is basically the opposite of skip. Right. So this means that we skip. So I just go to the rest of the parts, right? So we just collect children, parsed parts, and rule parts tail. But if we want to go in, then then we need to first parse the group entirely, right? So group, so parsed group is collect children. So I will try to collect the children from the parsed parts using the group parts now. And then there should be some parts that are parsed but have not been collected yet, which means that this collect children function should also return the things that we have not parsed. Can I have an like an anonymous type here? You know, collected is this, and then like the remaining. You know, remaining is like the remaining parts that I have not done anything with. Let's have it as a type. Collect result. Can I have a type inside of a function? I cannot, right? Because it's a camel. This needs to live in some, like over here maybe. Okay, what have I done? Where am I? Everything is red again. Oh, over here, and in was not finished like that. There we go. Yeah, so have the result, which says that we potentially don't. Yeah, so now we shouldn't fail if not enough values were supplied. This should just say we should only stop where we don't expect any more parts. That's the only time where I should actually stop. So yeah, too many values supplied, this should never happen. Not enough value supply should fail. because I expected there to be more. But if I don't expect anything else, then I should just say that I return collected is an empty list, and remaining is parsed parts. I'm not writing Rust. An equal sign. Yeah, so over here, when I'm doing the collect children that is inside, like over here, I'm matching the value, right? This means that, yeah, we need to say that collected and remaining is this. And then we say that we return collected is this and collected. So we have collected one more thing, right? That's how we do it. Semicolon. Value. And in this case, the value is an AST. So this part is supposed to be a child. So this is an AST value. There you go. That's right. Collecting AST print values. Values is unbound value. What? Oh, because I call it parts now. Because now I call it part. I'm going to remove this from the logging. It's fine. Okay, so I have parsed the group. Right? And I say that we have collected is the parsed group. And then the remaining is what we need to keep parsing, right? We need to keep parsing that. So we need to go into the remaining rule parts, right? We need to go into the remaining rule parts like that, just like before. So we collect children from the remaining parts. Now, the rule parts tail. And we have the parsed group. And then we return this over here. That it's not a binding name. This is going to be a group name. So a group name is going to be assigned to a group. Parsed group. A group of group. Parsed group is not a group though. This is string option into child. So this should be tuple of list or something. Yeah. This is the tuple of list. Let's create the tuple of list. Let of list. Of list is a thing which has string option and a list, and we convert it into a tuple like that. So this should be just list fold left function tuple name value add name value tuple. We start with tuple empty. We collect the list. Wait, the accumulate, yeah, hold on. Empty. There we go. So we have tuple of list parsed group. The expression has type AST child tuple. Yeah, it's a group where children is this, right? That's what we want. Disu used. Hello, hello. Children, collect children. So now collect children has the collect result. So it is collected and remaining is this. And then I say that if remaining, if we have some remaining things, then we fail. Too many values supplied, right? And then we have this collected. So this this thing is root where children is collected into tuple of list, right? Okay, there we go. I think this is done. This is the, it's already 600 lines. This here is difficult. Okay, now we need to figure out how to store this into the data structure. So since we have the syntax rule parts, yeah, since I have the parts, and the part is this, we have white space or we have a group. I feel like they should be unreachable here. But yeah, basically if we have a thing which is a group, when I insert, this returns a node, the updated node. Yes. But I feel like this should also return the final node. Now, type add, type insert result. No, no, it should not. We should instead have like the continuation of how to continue doing the things. Two-step. Hello. Oh, camel rewriting. Camel rewriting has been good. I have the language server working now. Instead of having the other features, we start with the language server. So we have hovers, we have formatting. Right, we have inlay hints over here, right? If I remove this, it's going to be shown in the inlay hint that guest is an int32. We have I can expand my selection. That's a feature like that. Yeah, like a bunch of LSP stuff has been done this time in the rewrite instead of the other features of the language. So the language itself is kind of like not really there yet. It's very, very simple for now. And now I'm also improving the syntax. Specifically, I am right now doing the... Are error messages also good? Not yet, not yet. They are even worse than before. Adding optional. Right now I'm adding optional groups to syntax definitions. Like you know, for example, an if could be like, you know, if condition, then, and then else should be optional, right? So we say else, like that. Why is this thing green? That's weird. Yeah, sure. But maybe you want to rewrite in OCaml originally? I was having two slow compilations with Rust. I wanted to do a rewrite anyway. I didn't want to do specifically in OCaml, but since my compilation times were so bad, it took a minute to recompile. I decided to go for the language that is supposed to compile fast, which is OCaml. But technically, I think still that Rust is a better language. And the tooling for sure is much better in Rust. Okay, complex, children, this should be root. Let me say children is root children into tuple map ast child expect ast. Okay. Selection range. Okay, now we need to fix the this part too. Okay, it's fine. Complex root. Just finding the spans. Just a span list. Yeah. This over here should be like a flattened thing. Yeah, so child spans, if this root is children. Should I have a group as its own span? I should not. Find map. Find span, start biggest. Okay, if I've found it there, then yes. Yeah, okay. So we have do you have similar issues with Zig LSP with comp time eval blocking some features? What do you mean? Similar issues to what? Comp time eval blocking some features. I don't know. I haven't used Zig much. My issue with Zig is that the language is too simple, which makes it difficult to write complex code. I don't remember having an issue where comp time eval blocks some features. Comp time eval is actually the good feature of Zig. the only good feature. Shit, I need to like let rec find in group. And have a function that takes AST group and returns span list option. I think function run. This will not work. Let's do that instead. So I have children. Then I'm going to have children to so child spans is basically find in group root, right? Zig LSP has a pretty weak LSP around comp time eval, such as doing completions for generics. For now, anyway, they plan to make a compiler server, which can help with some of that stuff. You're saying that the language server is not able to execute comp time, right? Which leads to bad completion with stuff that requires comp time, right? Yeah, it's weird why don't they do that? Like basically, you need the compiler itself to be the language server. It's my understanding that the compiler should be the LSP. LSP should not be a separate project from the compiler. When you have comp time evaluation, the language server should be able to do everything that a compiler can do. So yeah, I don't have that issue yet. I only made some simple stuff. But I don't know, it should work. The LSP has a really basic comp time engine they built themselves. Yeah, they're like, why are they doing it? Like, I feel like that approach is completely wrong. Why do they, like, it means that they have implemented two comp time engines, one in the compiler and one in the LSP. Why do you need to implement the same thing twice? I don't get it. Like, if they already have the comp time engine, why don't they use the existing one? There are probably reasons, I don't know. Okay, we have children. Tuple to sequence. Children is a tuple of childs. We have a child. Then I'm going to match child with, if it's an AST child, then I will do that. And if it is a group child, then I will find in group like this. And this is unbound constructor because this language is stupid. AST child. If I do that, then it will figure it out. Find in group child. There you go. All right, what is this now? Test parser. So now we need to fix the tests. Why did I make tests? Now we need to fix tests. If I didn't make tests, I would have already been done. Matches. Root. So I'm not supposed, yeah, like the tests are supposed to not work with the things, at least not yet. can I just say let children is root children into tuple map ast child expect ast, then it will keep working. I might want to have a to do here. To do make tests work with groups. Okay, it looks like I am compiled, but I feel like I have missed some things. Let's try to say run guess a number. Guess a number probably will still work. No, it doesn't. We cannot parse a group. Expect in the file got punctuation at rule. Yeah, so this is when I'm doing this syntax. Simple syntax over here. So this has not been parsed. This equal sign was not expected, right? Because I have never made the parsing of the groups. Parsing of the groups happens where? In the parser, right? It does happen in the parser. So I have a module rule here, a rule parse. So collect parts makes sense. But I want the parse. Yes. Collect parts. Oh, it's a different collect parts, right? Yeah. Okay. So we have the collect parts. We have an identifier. And the identifier is supposed to be was supposed to be previously the value, but now it's not always the value. Now the identifier might actually be a group. The identifier might actually be a group. I feel like the name is here, yes. Then I pick the lexer. And then we do this. If pick is raw an equal sign, then we do one thing. Otherwise, we do this other thing. So this is not group, and this is group. Right? So I need to say some group name. Right? And then we also need to have the parts and the quantifier. Okay, so how do I do the parts? How do I do the parts? I need to collect parts. Right? Yeah, I need to collect parts here. So parts is collect parts. Like that. I need to, although first advance the lexer, so we skip the equal sign. And then we collect the parts of the group. Actually, after the equal sign, I am expecting to see the... I'm expecting the next one to be an open bracket. I collect the parts. After the parts, I need to... the closing bracket. Let's expect next. We peek, and then we advance. Otherwise, we say expected this, got that. Yeah, that makes sense. So we collect the parts in between the parentheses. What are you saying? What did I just do? There's a syntax error here somewhere. Where? Why do I not see it? Am I blind? There is no syntax error. Where? Line 89, over here. This language lies to me all the time. I needed parentheses here, apparently. Why do I need parentheses here? That makes no sense. Oh, because of the let in? If there is just semicolons, then I don't need... No, actually, semicolons already means that I need parentheses. Yeah, that makes sense. Okay. Okay, so I have group, name, we have parts, and then we need the quantifier. What's the quantifier? So quantifier, I will match. I'll try to pick here. And then I will match. Quantifier. If we have the question mark, it's going to be some optional. And if it is anything else, then it's going to be none. AST. Syntax. Rule. It's just over there, right? Like it should technically, maybe I will, whatever. That's good enough. Expect in the file got question mark. Yeah, so like in this case also I should first say that we need to advance the Lexer to consume this token. Okay, so I have, it looks like I have parsed, and then we reached the unreachable when I was inserting the things over here. Yeah, so we have a group. So now when I am adding a part, which is a group, right? How am I adding the part which is a group into my data structure that's holding all the syntax? If we have a group and the rest, we need to insert. Like that's the thing that we are getting, right? To do, yes. Of course. So what do I do here? If we have group and rest. So I'm going to match. I'm going to match group quantifier with. If it's none, then I should just insert. So yeah, I should just continue. With the rest of the parts. No, not with the rest of the parts. So now the parts that we are trying to add to this syntax. The parts that I'm trying to rest to the syntax should be both rest and the parts of the group. So it should be also group parts. Group parts joined with the rest. Let's make sure that I don't forget any fields of this. So there should be a name, but name I don't care about. There is parts, and then there is the quantifier. This is group parts. So group parts are just joined with the rest. That's fine. That's easy because it's not optional. And then if it is optional, then I should insert. So I should, yeah, I should keep inserting just the group parts into the node. I mean, in this case, I should insert the things twice, right? With the group and without the group. So I say that node is this. So I insert the group parts. Or maybe like I insert without the group first. So like just the rest. Right? So this is inserted without group. But then I need to insert the group too. Right? So I need to also insert, once again, into this one. But then what are the parts that I am expecting to have here? We should have group parts. But then after the group parts, I should also have the rest. So it is the same thing, right? It is the same thing, but if it's not optional, then I only do this one. And if it is optional, then I do both with the group and without the group. Yeah, that makes sense. Maybe that's all that I need to do. Let's see. Probably not. Not enough values supplied. Beautiful. All right. Let's say that this is info. Let's first see what am I trying to collect. Right, so I'm trying to collect two values into core let. So we have a core let syntax, and it doesn't have enough values supplied. But core let is a syntax that doesn't even have the groups. And wait, colon. But core let should have two values. This is parts, right? But yeah, core let is a syntax with two values. Core let, right? We have two values. No, hold on. Actually, that's not right. We have one value. We only have the pattern. That's right. But there are two parts because we have a keyword. There's a keyword part, right? There are two parts because there's a keyword plus the value, which is the pattern. That makes sense. Let me try to see what have a... Yeah, I need to like print to debug this. Parts is list print parts, which is AST child print. Formatter into child into unit. It's a function fmt into function. If we have an AST, then we say AST print fmt AST, and if it is a group. Wait, is that even like the child? No, it's not. The parts are a list of... The parts are of AST parts. That's not what I want to print. I mean, I might want to print that eventually too. Wait. This is a child group. Children. Yeah. We just say print. This print. I have a print child. We just say print. This print child. Okay, that's fine. What I want is an AST part to be printed, right? Part. If we have a part which is a... So we have parts which are comments, right? And we have a part which is a keyword. Then we have a value. A value in this case is just an AST, right? So we just say print value. Comment, keyword, or an AST. So AST part print. Let's debug this. So we have a part which is a keyword let and main. Yes. Wait, hold on. This is correct, right? We have a keyword let. We have a main. This is what we're parsing, right? Let main in the beginning here. And this is correct. This, and then this says that not enough values are supplied. Why? Because I have a bug here in the collect children. Okay, since I have touched this, I have introduced a bug. If remaining... Oh, wait. So the problem is not enough values supplied. So over here, because we have an empty list. But this... Oh, wait. I see. This should only be done over here. This pattern is having priority over this one. Yes. That makes sense. Is that the only bug? There we go. I have parsed it successfully. Okay. Welcome to the guessing number game. Yep. Okay. Fast parser, log info. Let's change this back to trace. Okay, guess a number game still works. Now let's try parsing something with actual, like, so in theory, we have the support for the thing. If I say, by the way, let's try to run the tests. The tests still work. Okay. Now let's try to parse that thing which has optional things. I mean, we can just have this one, right? We can just have this one. Cast parse test interpreter. So this one is still being parsed successfully, right? But we want to support, since the new thing that I did is the function. Wait, hold on. I have removed the function and this still is working, right? So we can actually already see it, I think. We have the core function where argument is a scope, where body is this. Core function. Core function is only specified once with optional context group and the result group, right? Yes. Oh yeah. So like because this group is optional, we don't even see it in the fields here, which makes sense. We only have an argument and we only have a body. But but if I say with, underscore, for example, will it still parse? It still parses, right? It still parses. So now it says that we have a core function where argument is this and context is a placeholder. There you go. And then we can say with and then into also something else. And now the function that is parsed has argument, has context, has a result, and the body. So we have all the 4 parts now. Okay, and we also can do this. This also should be parsed. Okay. I think everything is working. Let's just restart the LSP so that we have the highlighting for it. So I have a with underscore. See? This is working. Nice. It doesn't format though. The cast language server crashed 5 times. Is it the formatter that crashes? I think it's probably the formatter because the highlighting works. So let's try cast FMT examples test interpreter. Yeah, so it says unreachable to do because I have a to do somewhere. Fail to do. Fail with to do. Wait. Oh, it's unreachable to do. In the cast formatter. Yeah, that's right. Because the formatter now needs to be able to print the parts where the part is potentially a group. Right, what do we have here? We have the rule parts and the parts that are actually passed. Okay. Parts are these. Oh, but the AST parts, they are not like grouped at all here. Should I have the groups here? Where I know, like, yeah, I should like know which groups have. Wait, yeah, this part should not even be here. You know what? Let's commit what I've done, but I will then. And then we will improve. Optional quantifier and syntax. It kind of works, but not exactly. In the formatter, I feel like what I need to change. So with the AST, when it's parsed, this over here is a flat list, right? But since I have like nested groups now in the AST, the parts should be part of the group. We have the children, which are like the child values, but we also should have just the parts. Like, I feel like this should not even be child tuple. It should be something else. Like we should have a mix of like part, a group. Actually, I don't know. I feel like we should just have parts is the part list, but we have the part also going to be a group. We have also a group, and a group is a group. Yeah, like these children is more structured than the parts. Parts we just use as like raw parts for reconstructing the syntax, for the formatting and highlighting. But children is the ones that actually like have names, or like the ones that we care about. This is about the AST, this is about the concrete syntax tree, right? Something. So when I print group, we ignore the parts. And when I print a part, which is a group, then we print group. Okay. Now, if I make, so now AST group has parts which we can ignore. We only care about the children in the compiler. Let's change all of the children into parts and children like that. Okay, that makes sense. There are no parts here now. Group, children, and parts. So like this is now the collecting. So collected is AST child. Oh my god, this is yeah. Okay. And to touch this one more time. So collect children. So we have a flat list. We have a flat list of parsed parts, and we need to collect it into a structured thing. So collect result is collected list of so this is just like children, probably what I should call this. And then we have the parts once again, which is AST part list. So this AST part and this AST part is kind of different. I think maybe I need to have a separate type here. Maybe I should have a separate type. Because the things that I'm collecting is a flat part. When do I call this function? Parsed. Yeah, I call this function over here. I made progress, ASTT. Parsed rev. This thing is AST part, but this should be a flat part. Should I say parsed part instead? I don't know. Let's have it somewhere. Type parsed part. It's very similar to the AST part, but it doesn't have the ability to have the group. So it's a comment of AST comment. Token comment or something. Or it's a keyword of token. Or it is a value of AST. And there is no groups here, right? This might be a spend comment. AST part. So this should be not AST part, it should be like parsed part. Right? AST part has a, yeah, it's just a token dot, yeah, it's a token comment, that's fine. Yeah, damn. Okay, so now over here we have this is not AST comment, this is just comment. And this is not AST value, this is just value. And this is not, so yeah, rule collect, parsed. This has type parse list, but we expect of that. Yeah, so rule collect is not AST part, this should be parsed part list into the AST. Okay, spans is this, so now we don't have comments here at all. And this is not AST. So parsed parts is parsed part list, and this should be this should be parsed parsed part dot print, I guess. Type module parsed part print formatter parsed part unit. Token comment print keyword token print value, and we say AST print token just say token shape print. How about that? Just simplified. Okay, now we have this. The following labels are not bound for this record. Parse. Yeah, because collect children returns the collected result, which has parsed. So we have the parsed list, remaining, and children. Okay, yeah, that makes sense. So we have parsed, children, and renaming, and then parsed here is going to be, since I have a value already, this should just be a value followed by the parsed. Collected is now children. Parsed. Parsed children. Hold on, what is this? I am going into the group. I'm collecting the children. That is the group. Then I'm collecting the remaining children. Right. So this is parsed. This over here is yeah, this is parsed group. I don't know, group parsed. And this is group children. Then I parse the remaining into parsed children remaining. Then I return remaining. I say that children is group name and group, followed by the children. And then I say that parsed is parsed. But the first thing is going to be a parsed group. So this is my group, right? Group, and then parsed. And this, yeah, this has a name. Yeah, that makes sense. Group is AST group. It's that. And AST group. This expression, yeah, this is a different group. Hold on. It's a different group. I have shadowed my variable. That group name is group name. This should be group name. There we go. So, and then the group needs also the parts. So the parts of the group is a group parsed. Group children is not being used. Yeah, because children is. Children is group children. No, group children is a list. Why am I returning a list here and not like a tuple already? Because it's easier to just add it to the beginning of the thing. And then only here I'm actually doing that. Sure, tuple of list. Okay, if it's empty, then we say children is this. Parsed is that. And remaining is all of the parsed parts. We say parsed. Children remaining. So we don't have parts here. We have the parts over here. Parts is parsed. And this is not collected. This is children. Okay. Is this working? Not yet. We have another part. This is the selection range of the LSP. Find in group. Children. Parts. Yeah, I don't care about the parts here. Semantic tokens. AST complex. So now we don't have the parts here, right? Now this is no longer flat for the semantic tokens. This one is also structured. So I say root instead. And this should be like collect from the group, you know? Let rec collect group. Is parts underscore, which is the AST group. In collect group. But this should return the token sequence, right? So now we sequence flat map. We no longer have that, right? Because this parts is an AST part. AST group parts is a part. So we have comments, values, keywords, or groups. Value, keyword, comment, or a group. Then we just collect the group. And that's all that I need to do. Okay, now cast simple syntax. Parts here are no longer there. No longer needed. Parts here no longer needed. Cast test. Parts no longer needed here. Cast highlight. Parts no longer are... Wait, parts are now not here. Yeah, this is same to the semantic tokens. So now we only care about the root. We print parts. Rule wrapped. Parts. I feel like we need to say let rec print group, where we have parts, which is AST group, and then we will print group root, and then we just print the parts like that. And print parts should know how to handle groups here. Or should it not? Rule wrapped. What is this? Wrapped is that. I guess print group should just be actually like over here then. Should you just end print group? Print group. I guess we still need rule wrapped. And that. Rule parts. So now print group should also rule wrapped. Right? Does that work? Fast highlight over here parts. We have a root instead. This is common print AST. Oh, this is about the HTML. Let rec print group parts AST group is parts into iterate in print group root, and then this should say that if we have AST group with print group, is that good enough? I don't know. It compiles. Does it mean that it works? No idea. It says print hello world and then unreachable to do. Unreachable to do over here has happened because print parts should now handle the group, and then the rest of the rule parts, and then this and then the rest parts. This is AST part, and AST part now is possible to be a group, right? Syntax rule, yeah. Okay, hold on. Well, and then we have group rest parts. So I will print the rest of the parts, but first we need to print the group. So this is a group rule, and this is the actual group. Rest rule parts. Parts. There we go. So how do I print a group? Wait, what? Print group. Print parts. Hold on a second. Print AST. Root. Print parts. Don't I just print group here? But I need to also say rule wrapped and group. So the group rule itself is not really necessary here, right? It says unreachable reached to do, which probably is this one. Unreachable. Print parts %A%A. Yeah. So they are not empty. So we have a option print. I will take had. List had is an optional. List age, list had opt of the rule parts. List had. That had opt is a function. Had, then some had. Anything empty, then none. Okay, yeah, let's do that. So this one should be printed using, since this is a rule, syntax rule part. Can I have a syntax rule print? And then we need to do option print the actual part, which is AST part. So we have a AST part print for the list head of the parts. This says that expression is type a rule, but expression is a rule option. Because it's a rule print, I want rule part print. Can I print a part? Module part. This part. Print this function. Formatter. Part unit. The parts are whitespace, keyword, value, or group. Whitespace. Keyword. Whitespace. Keyword. Value. Or group. Group. Groups have names too, right? There you go. Okay, so it says, wait, hold on. What happens? That's an entire exception that we have. Unreachable reached. Print parts. So we had a part which is a semicolon. Hold on. What? It's in the formatter, right? This one over here. So the it says that the rule part that I expect is a keyword semicolon, but then the actual value is a value, right? So we have a keyword. That makes sense. But how did that happen? Can I try format some hello world? This is literally at the beginning of this. We have a use std star, which doesn't work. It says that keyword use and the identifier. And the identifier is this. Yeah, so it's trying to, yeah, like, because this and this is different things. That's right. I have a bug here somewhere. This one doesn't even have the groups. Rest rule parts, rest parts. I'm matching rule parts and parts. Or am I might be not putting the keywords into the parts. That probably actually is what happens in my parser. Yeah, because I was previously just collecting the children, right? But now we need the parsed. And when I see the keyword, I'm just collecting the children, but I'm not saying that the keyword was actually parsed, right? Yes, that's right. So we say that let parsed children and remaining is this, and then into return parsed children and remaining, right? But I need to add the keyword as part of my parsed things. So we add keyword parsed keyword, the beginning here, right? This is parsed like that. Okay, and then we have FMT, and it does work. Okay, nice. And if I try to format this, this does not work because now it says unreachable reach print part argument. So this over here, we have a with keyword. If I remove the with keyword, it still doesn't. Yeah, because print args, group context, and this. Yeah. This actually, wait, hold on. This actually does make sense because I'm trying to match a group with a group, but it's not always correct. It's specifically in the formatting, right? I guess since I'm ignoring the group of the rule at all, I don't care if this is the group. Right? I don't know if it matched this specific group or maybe some other group. Yeah. Print group. Wait, but print group? It's going to be print parts? Rule parts? This is not correct. Yeah, this is not correct, actually. This is not correct. I do need to match the groups. How do I match the groups, though? How do I know if this is specifically the group that has been matched? In my parsed group, I don't have the names, right? I only have the parts. I don't know which group was matched here. But maybe similarly to how, like, so the parsed AST has reference to the rule, I should actually have in the parsed group the reference to the rule of the group. So the rule is basically syntax rule group, I think. Print group. We ignore the rule here. All right, we go forward. How long has it been? 2 hours. Shit. Rule. Actually, maybe we just say over here, we just say children, and then we just don't care for all of the rest. In the parser, when I collect, now I have the group rule. So this is group rule. Group rule. Group name is group rule name. And this is rule is group rule. Okay. Group rule parts. Root. Root rule is so root is not exactly a group. Root is not exactly a group then. Root over here is not exactly a group. It's a syntax rule. Hold on, syntax rule. Like, what's the difference between the rule? The rule has parts. I guess the rule should have the root group. You know? Yeah, maybe we should just have the root, which is a group. But this one doesn't have a name. We only care about the parts here. Oh my god. That's why we call it as parts. Does it mean that in the AST the root should not be a group? Or I can make this rule to be an option, but that's weird because it's only none for the root, and for all the other ones it's supposed to be some. Let's have an option here for now, and then I will say to do the rule is only none for root. So maybe I will figure out how to do that better later. Rule is some group rule over here, and rule is none in the root. Finding group selection range. Unreachable reached. We have a print value arg keyword with. Wait, but the argument has already been here. What? If I try to highlight this, not format, then it works, right? Highlighting works. But the formatting doesn't work. Because print parts says that it's the group here. Okay, it's because I have a group and I start from the beginning. That's why. Because print group starts from the beginning of the roots of the rule parts. That's right. Because when I say the print group, this rule should not be the original rule. This should be can I have an either? We have either. We have either the root one, so either a rule, syntax rule, or a syntax rule group. Right? Is this correct? And then print parts of the rule. Yeah, and we should still have the rule. This over here is group rule. Group rule. I guess in this case we just have the option. Syntax rule group option. That's fine. So the parts should be not the rule parts. This should be match a group rule with none. Then we say rule parts. But if it's some group, and it is group rule group parts, right? So if I have a complex over here, I'm having the root. In this case, the group is none. I mean, I can just say root dot rule, which is also going to be none here automatically. And over here, I also say group dot rule. All right. Okay, now we have done further. We have gone further. Unreachable reach, print parts. So I expect to have a group result. But we have a keyword that is this. That's right. Because the result is skipped here. We don't have the result. If we have the result, then it has a print parts group context keyword that. Wait, what? This also doesn't work. I expected that to work. Okay, fine. Should I just look at the formatter? Print parts. If I have a group, and I have a group, it doesn't necessarily match a group, right? Group result. Maybe I just say underscore here. No, I don't say underscore. Group. Group. This is the rule group. And this is the group rule. I just say that this should be done only when rule group is equal to group rule. Some group rule is equal, like that. Right? And otherwise, this means that the group is skipped. Right? So now, if we have a group, and then we have anything, it means that this group is skipped. So I print the rule with the parts. Group was skipped. Oh, holy shit, it works. Nice. First try. Okay. Restart language server. So now we have this code. It looks like I am deleting the comments now again. Why am I deleting the comments? If I have a comment, it's that. I feel like it's because the comment in the parts that I have parsed should be almost like one of the first things. No? Are you deleting comments? Maybe I'm not storing comments in the parts. That's probably it. I'm probably not storing comments in the parts. In the parser, if I have a comment over here, there you go. There you go. Found it. I'm going to do something very similar to this. But I am just supposed to add the comment to the parsed parts. And then the comment is preserved. Nice. Okay. Oh, that was a lot of work. I thought it would be easier. That was difficult. Hopefully there is no bugs. But we have a formatter. So now we have a function that is potentially having this. We potentially have the context. We can say the result type, right? And this is all like formatted successfully. The compiler doesn't work for those variants yet, though. The compiler doesn't work for those yet, but we're going to make it work. Okay, quantifiers with quantifiers optional quantifier works. Highlight and FMT. All right. So now we want to actually compile this, right? So over here we are inferring the fact that the print times is a function that is taking a string and returning unit, but we should instead just say that it returns unit like that, right? And then this should still work, but this doesn't work right now. We can format it, but we cannot compile it, right? It will say that expected AST not group. Yeah. In the core syntax function over here, we expect this to be an AST, but it's actually not an AST because the function core syntax is now accepting two optional groups, right? Is now accepting two optional groups. Can I have something? So like I want unnamed 2. And I want like, yeah, okay. So we have unwrap 2, which is unwrap. So unwrap has unnamed, named, but I should also have something like, will you write cast compiler someday in cast? That's the plan, yes. Hello, Major Who. That's the plan. But it's a long-term plan, probably. But now that we have the LSP, maybe it's not so long-term. We'll see. So basically the tuples now, I want like, since they have optional fields, I want to unwrap having like optional fields, you know, potentially. Do we over here say string set equal? Not. Is there other fields like string set dot disjoint elements equal? I feel like I need something like merge or union. Not union. String set. Can I merge? I want to specify the behavior if it exists in first set and doesn't exist in the second set. Why is there no merge here, like in a map? I can also try removing a named field, kind of. Like I want to unwrap with optionals. with optional fields, so that I still have the checks for the structure of the tuple. There will be merge. That's a long term. Oh, merge. I mean, merge is a nice idea, but yeah. The unicorn plushie, yeah. I tried to make like a simplified unicorn over here. You saw that? With like vector graphics, so it's like super simple. I don't know. Maybe it can be improved still. It's cursed. How to make it better though? Like I want to just use the simple shapes. So it's a circle. The eyes. Okay, how do we fix the eyes? I wrote it with code. You can try fixing it yourself if you want. Looks deep into your programmer soul. Yeah, maybe it's like the face should be different. Something. It's over here. The SVG. It's not even rendered correctly in the in this thing for some reason. And raw isn't actually raw. Yeah, it's like very small SVG file that I wrote by hand. I know why the hair and the tail didn't work here. That's weird. Anyway. Okay, let's ignore the fact that this is checked. Let's just say we have an argument and body. So argument is children get named argument into ast part ast child expect ast. So yeah, argument should be an ast, body should be an ast, but then we also have the we have context and result. Context is children. Tuple get named opt. Context. Into. So we need to get named opt. Get name opt is find opt. So we do that into option map function group into group children tuple unwrap single unnamed unbound record. I even had the autocompletion, but this stupid language wants me to write that this is an AST group. It's an AST. Oh yeah, it is an AST child actually. Right? Which means that it's not always a group. So it should be child AST child expect group. And then we that. So expect AST and expect group. Like that. Let group be this in group children. There we go. Okay, so we have the context, and very similarly, we are going to have result. So we have a result and that. So a context is an optional AST child. This over here should also be AST child. Expect AST. Hello, Pigorli. Yeah, there you go. So result is an optional AST. Context is an optional AST. Right? There you go. So this should still compile, but it should basically right now ignore the context that I have written there at all. Completely ignored. Let's for now do the result, right? So this is a function body. So basically the body, if we have we say match a result with none, then we do nothing. But if it is some result, then we will say that result is compiler. So I need to evaluate that as a type. Compiler state interpreter. Interpreter. Module interpreter. Interpreter eval. Result. Let's change the eval to be expression and then state, so they can pipe it properly. No, let's not do that. That's too much work. Okay, result is AST, so we first need to compile it. Result is compiler. Compile. In the original one, we need to compile expression result. And then I need to say that the expression should be a type. I have done that already before in the type description. Let me say over here, I will extract that. Oh, and then the expected type expression that I store here. Can I do it without copy pasting? So in this case, I want to store the actual expression, which is the thing, because I want that for the thing. Yeah, wait, yeah. So like the things that I evaluate at compile time should still be stored for the reason of the language server. So I should not just evaluate and forget the things, right? I should also, yeah. So I want an API like this, you know, expected type expression and expected type is a compiler like evaluate. So compiler can evaluate the things, but it will return me the expression too. And I want to evaluate like the AST, which is the expected type. In this case, specifically, I evaluate a type. Maybe I will have that as a method. How about I just evaluate the type with C as argument? Like that. Signature for this package module could not be inferred. What is over here? Can I not pass the first class module to another function? I should be able to, right? So let's say that this over here is the function. Let's have it in the compiler, maybe. You know? Eval type. So eval type has a module C, type S. Beautiful naming. So I return in the end expected type and expected type expression. An expected type, and this is the so the AST that I want to evaluate as a type, right? So yeah, if we have a result, then I will just say that result is compiler evaluate as a type. This should be C or something. Current compiler. I would say compiler evaluate type using C and result. And then if I know what the type is, then I say body type inference type expect. So the body type should be equal to the result. Like that. And then I need to store somewhere the result expression itself. Let's see, this should work. It doesn't work. Cannot unite a type and a unit. That's right. Okay. Okay, now we have this other issue where I specify that this returns a unit, but we have two different units. We have a unit value and we have a unit type. And the type of this is a unit, but I expect this to be a type. And we have this problem once more time. We have this problem one more time. Oh. So the way I solved it previously was that I had a dedicated type expressions, or I made a polymorphic unit, which sometimes is a unit and sometimes is a type unit. I feel like I need to reintroduce the type expressions. For now, though, let's say that this is a type unit, like that. I will do that. Or syntax. Compile. I'll have like a syntax, similarly to unit. I will have the syntax for unit type. And the syntax for unit type is just having a constant, which is the value type, which is type inferred type unit, you know? These are two different units. Unit and unit type. And then we want to have a syntax for the unit. So we have syntax core unit, and we see syntax core unit type, and this one is going to be like type unit, like that. Okay, then this works. Okay, beautiful. We'll fix that in a bit. Unit type. Remove. We will introduce the type expressions instead, I think. And where we expect the types, we will try to compile them as type expressions. Down, down, da-da-dum. So now if I try to restart the language server, this works, right? But I cannot hover on this thing. I cannot hover on this thing because this thing is getting erased from the compiled stuff, right? Since I have evaluated this, I am not storing the thing that I was evaluating in the intermediate representation, but I kind of should, just for the reason of the LSP, I guess. So in the core syntax, when I say that I have this result expression. So the expression function should have the result expression. Like since this is specifically about LSP, I feel like maybe I should store it. Like, you know, like I want to know that it's already evaluated here. Evaluated or something. Evaluated result. Like it's evaluated already. Right? It's already evaluated. Similar to how type ascription in the data is already evaluated. Feels weird storing this into the intermediate presentation since like specifically for the LSP, but what are the other choices? I don't know. So the print expression shape should ignore. the evaluated result. I think the type of is going to ignore that. The initialization of the expression is going to ignore. I'm just figuring out the type here. And then over here, I will say that we have, so this is going to be a result expression. Which is basically a result into option map. Like that. And then we have the evaled result. Is result expression. When I hover, so now when I hover, I should be able to hover into the evaluated expression too. That's the reason. So we say option or else hover expression evaluated result. Well, evaluated result option map hover like that, right? Option and then the expression has type hover info option, but the expression was of type A into A option. Oh, because position is also needed. Okay, because hover is kind, compiled, and position. Okay, function expression hover expression position. Okay, sure. And then inlay hints should be written in this expression to evaluate result. Okay. Sequence append is weird. Sequence 1 and sequence 2. So if I pipe it, it's going to be reversed. But for inlay hints, I kind of don't care, I guess. We just have a sequence of them. Or do I have, hold on, maybe we can have sequence flat. We have a flat map. Sequence concat. Yeah, concat. We have a sequence of sequences. Yeah, let's just have a list like that. And then we say list to sequence, and then we say sequence concat. Right? That's the same thing. And then we have a sequence of these, and we can have inlay hints of the pattern, inlay hints of the body, and then we have evaluate result into option to sequence, into sequence map function expression into inlay hints. Map using inlay hints expression. To sequence, this should be flat map. There we go. Okay, it works. Let's see if we can hover on the things. So we know that this is now a type, which is a unit type, right? I can hover on this. So the thing is, we can have arbitrary expressions here. We already have the compile time evaluation, right? So we can say, for example, unit and then type unit, right? So this is a unit and this is a type unit, which is returned in the end over here. We can have any arbitrary expression in the type position. Nice. Let's try get rid of this ugly type here. Our result type functions. Okay. So we want to, yeah. So what this means, we're going to say that the cast types. We now are going to have a new type of an expression. So right now we have an expression, an assignee expression, and a pattern. But now we are going to have a new one, which is going to be called a type expression. So type expression shape is type expression shape. Data is data. Sure. What do we have in the data? Span, type, and type ascription. Well, I mean, type ascribing the types and like having the types, like because the type of the type expression is always going to be type. I kind of only need the span there, but it's fine. Maybe we can always store it there. Fine. To do technically only need type. Only need span for this. We'll see. Maybe I will get rid of that. Type expression shape is. So what do I prefix this? TE, type expression. So so a type expression is one of. It's either a unit. We can also have the not inferred types, by the way, so we should be able to have a placeholder. Although should it even be an expression? That's more like a constant, right? Nine emotion. Hello. So yeah, let's see. We have a unit. We can also have the type expression, which is calculated using a normal expression. Just any expression. So we evaluate anything and we expect it to be a type. So normal expressions evaluate to values, and that value is supposed to be a type. Sure. I think these two for now are going to be enough. I'm going to add to it later. This works. Yeah, so, and one of the expressions, I guess, is going to be a type expression. So expression can be a type expression. Expression type. Should I call it not type, but tie? Just because that's what we do everywhere else. Sure. So we have expression type of type expression. So an expression can contain a type expression, and a type expression can contain a normal expression. Nice. Nice. Now let's fix the things. Now let's fix the things. If we have a type expression, then we should have a type, and then I just print that, right? So this should be print type expression. And print type expression is a function for matter into type expression into unit on fmt expression into fmt shape data print type expression shape. Okay, and then we have a print type expression shape matter type expression shape unit function fmt into function. If we have type expression unit, and we just have opening closing bracket. If we have type expression and we just say expression and then print expression. Pattern match is non-exhaustive. When I evaluate expression type, expression, it means I need to evaluate type, expression. So we have a function that's called evaluate type, which is state into type expression into a type. Evaluating a type expression should result in a value, so this should be always a type, like that. Type expression is not known. How do you know what an expression is? Oh, because it's over here. Makes sense. Yeah, let's see. Module type expression. I guess we can do expression. Expression type. Type is type. T is type expression. Print type expression shape. Type expression shape. Print is print type expression shape. Right. Type expression. Did this work now? Oh, because we don't have type expression, we have instead expression type. Yes, okay. We have that, and then we say what? We just yeah, just match expression shape. So now we only have two. If we have a unit, then we are going to have a type inferred unit. Most of them are going to be inferred, I guess. If we have a type expression, then we have expression. In this case, I say that I want to say value is evaluate expression. Right? And then I say value into expect type. Like this value is supposed to be a type. Okay, that's the simple part. When I initialize an expression, if I have an expression which is a type, right, then we say that that the type is going to be a type, right? The type of a type expression is type. We don't care about the expression at all here. Yes. In the language server hover, if I'm trying to hover, expression type expression, then we'll want to try to hover type expression. So now we have a new compiled kind, right? We have a new compiled kind, which is going to be a type expression. So this is expression type compiled kind. And if we have type expression, then we have compiled data here. If we have a type expression, then this is update data compiled with data is f compiled data. Sure. What else do we want? Core syntax. So now we have the unit type. This is going to be removed completely. Instead, we just have a unit. So a unit in case we are trying to compile a unit. So a unit can be an assignee, a pattern, an expression, and now it can also be a type expression. So this it can now be a type expression unit. Should I initialize them? Yeah, initialize type expression, sure. This is unbound constructor. It's because I need to just have the function that will be called initialize type expression. span expression type shape into expression type. We have function shape span shape, and we say shape data is span, type is type type inferred type, and type description is none. This one is very simple. Okay. This expression should not be constructed. The expected type is span. Span. All right, now let's see. Can a scope be a type expression? It can be, because we can have a type expression inside parentheses. Sure. So if we have a type expression, then we should say compiler compile type expression expression. Yeah. Sure. If we have a placeholder on the type expression is basically a constant, right? It's basically a constant value, which is new not inferred type. So I can introduce a new, I don't think I need to introduce a new expression type for that. We can just use the type expression, and then expression is expression constant, and a value is a value type, and a type is type new not inferred, right? Let's do this in steps. So if we have a type expression which is a placeholder, an underscore, then we say that the type is new not inferred. Then I say that value is this. I convert the type into a value. And then I say that constant is a expression is a constant value into initialize expression span. And then I want to have a TE expression constant, initialize type expression. Span. And by the way, I have now figured that over here we need to do some more stuff. So if the type expression, I just, yeah, we don't say that the expected type of this is that. I still need to match the shape with the things, because if it's a unit, then I will not do anything. But if it is an expression, then we know that the type of this expression, right? We know that expression type should be inferred as type you know. You can just do it once in the very beginning, I guess. So unit type is no longer a thing. If we have a function, then a function cannot be a type. It's a function. Function is a function. Function type is a different thing. Okay. Yeah. Now let's see, we have a simple token. This should be very similar to expression, I think. If I have a type expression, if I have a type expression, which is a simple token, then this should actually be very simple. I should return type expression, and expression should be compile state expression ASD. Initialize type expression span. That. If I have a type yeah, like this is just going to be the same thing. I'm not going to make a dedicated things for that. Okay, if I have a hover type expression, so yeah, this pattern matching is not exhaustive. So if I'm trying to hover a type expression, then I'm going to match compiled shape with, if we have type expression unit, then none. If we have a type expression, and we have something else. Compiled shape. Well, what am I trying to do here? I'm trying to find the hover option, hover thing. Yeah. So this means that I will just hover expression. Position. Hover type expression position. Okay. Hover specifically. So if I'm trying to hover specifically a type expression, we say compile, the type is compile data type. Span is compile data span. Definition mode. Is defined not here. Or actually none. Actually probably none. Because we don't have the type expression binding, I think. Because that's through going through the inner expression. Inlay hints. If I have an inlay hint of a type expression, we're going to match compiled shape. It's thinking that is not the correct thing. Match. If it's type expression unit, then it's none and empty sequence, right? This is the inlay hint for the current one, and then the inner ones. Type hint and the rest. Yeah. If we have type expression, then we have none and inlay hints for type of expression, expression. Then we have inlay hints for expression, expression. If we have a compiled expression, which is expression type expression, and we say none, and inlay hints for type expression, expression. Is this all? Success. Maybe this is all. Okay. Restart language server. Looks like it doesn't work. The compilation didn't work. There is no core syntax for unit type. Right, because we no longer have the type like this. Instead, I should be able to do this. This is not going to compile either, because this is going to say that we like it still is evaluating this as a normal expression. But I want to have this function that I made over here, which is called somewhere evaluate as a type, right, in the compiler over here. So evaluate as a type, and AST means that I want to compile it no longer as an expression, but now as a type expression. Right? Now we have it as a type expression. And now I evaluate not the thing, I evaluate the type expression. And I no longer need to expect the type, because I know it's a type expression. Right? Now the evaluated result should be not an expression, because the result is a type. This should be expression, type expression. And type ascription should also be not an expression, should be a type expression. In the inlay hints, we say that this is a type expression. Over here, this is a type expression. And this is a type expression. And this is also a type expression. Nice. Okay. Does this compile now? It does compile. Okay, good. So restart cast language server. Now we can hover this. This is a type unit now. This is not a value unit. This is a type unit. So here's the thing. If I make... Okay, let's try this. Let's try this. But I should have a dedicated type expression like this, you know? So unit type is what? Unit type is just unit, like this. This should work, but it doesn't. As you can see, this has been inferred to be at... So the type of unit is unit. It's a value unit, not a type unit, right? But I want this to be type. And this just doesn't work now, right? This doesn't even... Wait, hold on. This doesn't even parse? What? Parse. Unexpected equal sign over here. Oh, because type is a keyword, right? Right. So let's change the syntax a little bit. So we have the unit type. This should be removed. We should instead say core type expression. So type expression is just type followed by the expression. You know about sorting? It's probably in language called B. I know a little bit, yeah. I don't remember though. B language sorting. Is there like a thing that's not a video? On the GitHub, of course. Examples. Echo. Main. Yeah. Yeah. I don't know. It's just C, right? It's basically C. I think. I know a little bit. Not a lot. But I think he's a fan of C, right? It's probably a C. An expected equal. Yeah, so we have two things. We have two things now. I should have the type expression, but since this is now a keyword, I should also say syntax core type, just the type. It's just a single type keyword, so this should also be parsed now successfully. Right? It's parsed, it can be formatted, but this is not compiling because compiling is going to say that there is no core syntax type. So let's implement that. Type. So a type is a very simple thing. It's just returning the type of a type, right? It's just a constant. It's just a constant type. Children must be empty. Assignee. Yeah, so we cannot assign to it. Type cannot be assignee. Type cannot be a pattern. If we have an expression, then it is a constant, where shape is a type. Type. And if it is a type expression, then it is a type expression constant. And type is type inferred type. It's very negative outlook. You're telling type can what it can't be, but not what it should be. Well, a type can be used in a place of a value and in place of a type. Okay, and then we want to have the type expression too. Type expression is type expression. This should be let expression be children into people wrap single named into AST child expect AST. Then we say that so this should be a type expression. If it's expression, then we just say expression. Otherwise, we say this expression. And then we say that expression is compiler compile expression. And then I need to edit type expression here. Okay, so this doesn't work now. Okay, so now this example doesn't work correctly. So what's the problem with this one, right? So the problem is that this is a type, of course, right? But this is still a value. This is still being treated as a value. So we want instead to have the type expression like that. But that will still not work. It still is not going to work. Wait, hold on. Cannot unite a function and a type? Wait, what? Where do you see a function? Where do you see a function? Hello? Don't unite a function and a type. Because a function is not a type, of course, right? A function is a function. I need to have better like error reporting, which gives me the where like, and actually like if we're talking about the LSP, I should have the diagnostics in the VS Code where the error is actually happening. There's the diagnostics API that I have not implemented yet. We should. Okay, let me just first fix that somehow. If I say type underscore, type like that, this... Oh wait, this was supposed to work actually, hold on. If I comment this out, then this works. Hold on, so unit does not work. Why not? If I say let underscore be type like that, it still is trying to be a function. Okay, where do we see a function? I don't see a function anywhere. So it's probably in the compiler then. In the initialization, do I have some functions here? What I can do though, hold on. What I can do really easily is that I can add a stack trace. Here, right? Wait, is there a way in OCaml to like inject this stack trace or something? Print exception. Can I can raise with backtrace, which is a raw backtrace. Can I like I can register printer, record backtrace. Like, can I have a backtrace from the cast file? Print, raise, backtrace slots. Slots of raw entry, status. I don't think I can, right? Set unquote inception handler. String of extension constructor. String to string default. Use printers. Lot. Yeah, I don't think I can. Like, can I not have like the cause? I won't have a chain of exceptions in OCaml, right? And I have a chain of exceptions. OCaml. No. OCaml exceptions are not chainable like Python or Java. There's no built-in exception chaining. So I need to have a custom exception which will have the cause. Yes. But I don't want to like but I don't want to catch all of the exceptions then, right? That's weird. I mean, I should just ideally have a custom exception anyway, which is like compilation exception or something. Instead of using the fails like I'm doing here, right? This is inference exception specifically. We cannot have the hierarchy of exceptions either. I mean, what I can do, like, you know, I mean, I can just say try with, you know, if we have a exception, you know, then I can re-raise the exception. Raised over there. Will I see the re-raise here? That's not the one that's failing. Not initializing the type expression. Somewhere else, I'm having a function. Like, let's do it over here. Try with exception. Raise exception. Will I see that now? That it is re-raised? Re-raised, yes. So it is re-raised here, and I can... and I can attach some information here. So I have the span, right? I can say, like, while compiling this thing. Right? I can say, like, log error while initializing. Maybe I can just log it for now. While initializing expression at span print span. Right? Something like this is what I want. This will be while initializing type expression. This will be while initializing pattern. And this will be while initializing assignee expression. So I should just be able to see it in the logs at least, while initializing expression over here, right? So this is expression that I'm trying to initialize. Interesting. And it says cannot unite a function and a type. But which one over here is a function? What? That's weird. Initializing an expression. An expression is a type expression. So we have core syntax that's called type expression. This one, right? That's right. That's actually correct. Hold on. It's weird that it says that it's a function somewhere. But an expression in this case should be compiled as a type expression. I expect a type expression to be an expression. So we say expression type expression into initialize expression. like that. And if it's a type expression, then I guess we can have nested types, why not? Initialize an expression here. Okay. So hold on. You know what? Let's do handlers. Let's do more information here. So where am I doing the core syntax? Where am I doing the core syntax? We have these handlers in the cast compiler. Let's do that. So I will try this with exception. Then we raise exception. But I will also say log error while processing core syntax at name at span print. What's the span here? AST span. Okay. So it says, so I have been compiling the entire thing. While I'm doing this, I'm compiling that. Then I'm compiling this thing. And then we have the core syntax apply. Oh, wait, I see. Okay. This has, okay, I understand. So this has been parsed as application of a function type, which is not a function, it's a type. If we, yeah, so this is actually parsed incorrectly, I guess. This is actually parsed incorrectly. So we have two rules, right? This rule starts with the keyword type and is followed by an expression, and this one is having a keyword type which is not followed by anything. So if the type is actually followed by parentheses, because we have the priority of 1,000 here, it's because of the priority of 1,000, so this over here is supposed to be the priority that is higher, so it doesn't work. So we should instead say that the type expression, I mean, I can just say that this can be of the same priority, so it's like associative. Like just a right associative thing. And then it's just going to work. Yep, there we go. It was just parsed incorrectly. Okay. All right. So now we can see here, unit is a type, which is a type unit. So this unit over here is a type. It's not a value unit. If I say let unit value is this, right? So this is a unit type and this is a unit value. You can see that they have different types. So this is two different things. Now I want to also say that if this is inside of the scope like that, then this should also work. And this should also work, but this is not going to work. Oh, wait, it worked. Oh, because the scope of a type expression, yeah. No, that works, right? But if I say something like, you know, if I say something like semicolon here, which is still correct syntax, this is not going to work because this is now an expression and not a type expression once we get to the semicolon. Should it not automatically go into the expression? Should I like, so in order for an expression to be a type expression, we have a type keyword, but we go backwards kind of automatically. Or I can introduce the syntax for a semicolon that is a type expression. So like, what's the difference? The difference is we have A and B, and we expect this thing to be a type. Then the first thing can be a normal expression, but this thing must be a type expression still. right? So there should be a type expression with a semicolon, basically, because of that. Anyway, maybe I'll do that later. This is good for now. This is just me having type expressions. All right, what next should I do? There's a lot to do. But what should I do? Maybe I should initialize all of the types of the expressions immediately. There is one that I still have not done, which I had in the old implementation. I should have the place expressions, so that we can have like references and stuff. So whenever I say like let x be y, I don't necessarily need to know the value of y. Because so let's say that I have a tuple. Tuple is like 1, 2, 3, right? Tuple is 1, 2, 3, and then I say that x is y, right? I should be able to just say let x underscore underscore be equal to y. So if we have a language with move semantics like Rust, then this would only move away. This would only move the first thing from y, from the tuple, and not the other two elements. I mean, the 1, 2, 3, these are just integers, so they are copy types, so that doesn't matter. But if it was a move only type, then these would still be living in the same places. So this right side of the assignment is supposed to be a place expression and an R value, right? This over here is an L value, this is an R value. In the C++ terms. This doesn't work right now. There is no core syntax comma. Yeah, I have not implemented the tuples yet, which is fine. Which is fine. We can have the place expressions before the tuples, I think. Should I not? Because place... This place is a lot to do. Let's instead do something else. I want to see the diagnostics. When something doesn't compile, like if I say ASD here, right? This doesn't compile. I want to improve the error message, maybe like the error messages first. We expected and the file got let. So this specifically is the parse error. There are different errors that we can get. We can have a parser, a lexer error, a compilation error, and evaluation error, right? And I want to see the errors in the editor too. And I need to also have a better reporting of that anyway. This one says expected and the file got let. Should probably instead say that it is unexpected let over here. Hello, Nigel. Diagnostics. LSP types diagnostic team. What do we have here? We have code description, data, message, range, related information, severity, source, tags. There's a lot there. LSP diagnostics API. Diagnostic. Represent a diagnostic such as a compiler error or warning. Diagnostic objects are only valid in the scope of a resource. The range at which the message applies. Range. The diagnostic severity. To avoid interpretation mismatches when a server is used with different clients, it is highly recommended that servers always provide a severity value. Severity. Error, warning, information, hint. The diagnostics code, which might appear in the user interface. An optional property to describe the error code. Code description. An href. And URI to open with more information about the error. Source. A human readable string describing the source of this diagnostic. E.g. TypeScript or superlint. What? What does this even mean? The source of these diagnostics. What does this even mean? The source is TypeScript? The diagnostics message. There's message and there's code. I don't understand which one. What's the difference here? There's message and there's code. Code might appear in the user interface. The message might not appear in the user interface. Because of my AST parser, as not only competitor to Rust, Zig, etc., it's also competitor to Bison and Yak. I have no idea what's... I have never used those. Bison. Yak. What does it do? General purpose parser generator that converts an annotated context-free grammar into deterministic LR or generalized parser. Yeah, I guess. I guess it's kind of like a parser generator. An array of related diagnostic information. When the symbol's name within a scope collide, all definitions can be marked via this property. Data, LSP any. Diagnostic tag. Unnecessary, deprecated. Clients are allowed to render diagnostic with this tag faded out instead of having an error squiggle. All right, what's the problem? What's the difference between a message and a code? This is diagnostics code. Integer or string, because a code might be an integer. I don't understand this. But I guess we use message. A human readable string describing the source. Let's try, there's code description. Property to describe the error code. Like it's error 123, for example, right? Like in OCaml, they have the codes for errors, right? This is warning 27, like that. Is that shown by the VS Code and not just part of the text? Let's try to have a diagnostic list. Let's have a single diagnostic, which is going to have tags. Is an empty list. Source is none. Severity is some warning. Code. Done. Code description. Done. What else do you want? Source, severity, related information. Data. Done. Let's have the same order as here. Range. Severity. Code description. Source. Message tags. Related information and data. So the only one that is not optional is the range, actually. So tags also can be none here. Message should be a string or a markup content. So, but in this library, the message is not optional. Okay, fine, sure. Let's have string hello diagnostics. What's the other file that I changed? That one? Okay, sure. Severity. Severity T. Okay, this one is like, okay, sure. Warning. Error. Okay, range. Range. State. File state. Let's highlight the entire file. Let's highlight the entire file. State. Parsed, compiled, Fury. Let's see. Let's see. So we have not parsed, we have not compiled. I want the full file here. Actually, I guess let me make this to be an option. Or not option. Match state let's just say that it should be parsed. So that then I will show some diagnostics. Parsed, parsed AST span. So like the entire thing that I have spanned is going to have diagnostics on it. Can I do that? Unbound record field. Oh my god, this language, I hate it. I need this to be over here, otherwise it doesn't know about this field. Right. Yeah, let's do that. So we should highlight the entire thing. It should say hello diagnostics. Let's see if that works. Restart language server. There we go. So we have this squiggly line around everything. It says hello diagnostics. There we go. That works. That works. Nice. Now we want to do the actual diagnosis. So what's my file processing state, right? This is if we have successfully parsed. This is if we have successfully compiled. But if not, then I should have like, nice, just like a camel. True. I should do what? Like let's start with if I have not parsed, right? This is an optional parser result. And if it's not, then I should just have an error. How about I just have Lexer error here, which is going to be Lexer error option. Right? I cannot store an exception. Yeah, I cannot store like an exception. We will need the Lexer is cast Lexer. Maybe let's start with actually not the Lexer. Let's start with a parser error. Is a parser error function. But the parser error is like a function, but I can have a type, right? So we have an exception error. There you go. So what I want instead, is I want to have an error of type error. There you go. So we are going to have an exception, and type error is this something something, right? And the function error should also take the span as an argument. So the error has a f, which is what did I have there before? Yeah, it's just like a function. So like how to print it. How to print it. So message is like stored as a thing, which is formatter into unit, like that. And we will also have the span attached to this error. And potentially I want to have like, I guess, the parent error, right? So I have an error, message, span. Like if this is unhandled exception, then I should say parse error. This, which is message. And then I want to say at span print span, right? If this is unhandled. If I say an error, then I raise an error. So there's a message. We raise an error with message and span. This is a function span format, like that. Okay. And if I expect end of file, I raise error f. Oh, what is this? Wait, I try to... Oh, yeah, if there is a Lexer error... then it is this error. Right, because I expect the end of file, this is throwing the Lexer error. That's right. So Lexer error... message. We'll change the Lexer error later too. This should be raising error. message span is Lexer position. Yeah, by the way, so like the end of file, this should be like a position. This should be a position. But I want a span, so this should be a start is position, and finish is also position, and file name is Lexer source file name, like that. Okay, so now whenever we return an error, I should give it a span. But what should be the span actually? So I'm trying to parse expected rule name, right? So this is when I'm parsing a rule. What should be the span here? This is the token that I'm trying to, and the token was not expected, yes. So it should be token span here. This should be token span. 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 Token span. No, this one should be peak span. Okay. Duplicate rule is the, so yeah, if we have a duplicate rule in the syntax, then could report it as, so the span should be the span of the entire rule. Do you have the syntax rule? Syntax rule doesn't have a span. I'm inserting this thing. Maybe this should say invalid argument or something, because adding the syntax is like, or I add the span of this rule as another argument, because the rule doesn't necessarily come from test code, I guess, here, right? Like I don't have the information where the rule was defined, or maybe I should have the information where the rule was defined. Should I? So there's syntax rule should have name, priority, parts, wrap mode, but also where was it defined, right? Span. Should I? So that we can go to the definition of the rule. Actually, wait, hold on. Because we have an extensible syntax, does that actually make sense for a programming language with extensible syntax to do? So I can hover on a semicolon and I can go to the definition where the semicolon was defined. You know, so if I click on the semicolon, it will give me the definition of the semicolon, and I can hover it, see the priority of the syntax and stuff. Maybe that would make sense. So this should be error rule span. And then there's also existing one, right? So we can have some, yeah. Maybe we could have like more specific. Yeah, I feel like instead of having this as a format string, maybe we would have like the different exception, like different exception for every kind of error with more structured data and then just a string that is formatted. Yeah, that would make sense probably. For now though, we're going to keep that. When I parse and I collect the parts, I want to know the span. Of the parts. So we have parts over here. Syntax rule part list. Span. What's the span? I feel like I need to just record the original position of the lexer. I think I should just say something like that. Start is lexer position. Not lexer position actually. Lexer peak. I get the peak token and then I have the start of that. You know? And then in the end I say that finish. Well, it should technically be like the last parsed token or something. Does the syntax variant of AST or node or whatever already have the span? Yes, but in this case the rule is not the AST node. It's not an AST node yet. The AST node containing the syntax definition has the rule inside of it. Finish. Let's just say lexer position lexer. Wait, what is lexer position even? It's lexer reader position, which is actually not correct. Because I have the peaked one. To do. Not correct. Maybe it should be position of a peaked token. Maybe. So span is a start, a finish, and file name is a source file name. Okay. So this is when the actual parsing is happening. So I'm saying that we have an unexpected token. So then I say, print this at token span. Expected semicolon. Got this. Token span. Okay, any other things? Comma is incorrect structure. This is for the simple syntax. AST span. Kamiluko, hello, hello. How's it going? It's going pretty well. Slowly but surely we make all the features. And for some reason I'm working too much on the language server instead of the language. But it's good. Maybe this is actually the correct approach. I don't know. Because if we have the language server, then working with the language is going to be very nice, right? Process file. This should return the file state. Okay, over here we expect to see the parser error. Parser error. Okay. You asked me recently why Gentoo and not Arch. That gets me thinking. I gave Arch a go. Those binders are significantly slower and cause higher CPU usage, and thus temp on my little Lenovo. It makes a significant difference because you are compiling. So with Gentoo, you're compiling for your architecture specifically, and Arch is bloated because it's supposed to work for most people. Okay, I thought it would not be actually a big difference. Is it like Lenovo X1 Carbon Intel 10th Gen i5? Is that like, is 10th gen the new gen or the old gen? I have no idea about the gens of Intel. Every developer has development phases and pretty-5 phases and documentation phases. Yeah. I guess. I'm not looking forward towards the documentation phase. Parser error. All right, so yeah, over here. Where? Yes, over here. See, we parsed and then we try catch. I'm catching all of the exceptions, and if if exception happened, then the parsed is none, right? But I should instead say over here that we have a parser, error, and parsed. In this case, we have none, right? So if we have parsed successfully, then we have no parser error. But if I have failed parsing, maybe we should like get rid of this branch, or maybe this should like have a notification that the that we have had a crash or something. Like message about crash or something, if it is like an unknown exception. But if it is specifically a parser error, right? If it specifically is a parser error, so we have message and we have span, right? I mean parser error. In this case, we return error and none. Some error and none. There we go. So now we have the parser error, and I can report this to the diagnostics. Parser error F. Lexer error F. So if we have parser error, then we now have a message and span instead. And in this case, we should also say that test properly failed. Like that. What about here? I don't want that. Okay, everything is compiling. Now we want in the diagnostics. In the diagnostics, we don't want to highlight all the file. Instead, we say that instead we say that parser error is parsed its state parser error. And then we say that the range is parser error span into span to range. And then the message should be parser error f message. Something like that. Let's check. Restart language server. Okay, so right now everything compiles and it works, right? But if I say something like a semicolon here, then it's highlighted. We expected and the file got semicolon. There you go. There you go. And I know where the error is in my parser. That's good. And then we can have like other things. We should have like the other things in the compiler too. So if something fails to compile, like if I say over here, that string is an int32, this will fail to compile because this is expected to be a string. Or if I say that it is an int64, that it doesn't compile because it's not even, the compiler doesn't even know what it is. Could not find int64 in scope. Parser error LSP diagnostics. Let's have this same way, but about the compiler. So this is specifically parser error, right? Option to list. And then we add that to compiler error to list. This also means that I only have a single error of the compiler for now. But in order for it to be not a single one, we need to continue compilation after the error happens and like stuff. Maybe we'll have like error nodes, the types, error types and shit, right? All of that. So compiler error, we just stored inside of the state 2 maybe, you know? Compiler error is going to be compiler error. I'm just using fail width right now, I guess. So over here we say compiler error is none. And if we have the error over here, compiler error, say compiler error is some error. And now we need to say that compiler should have an error. It's going to be like similar, it's just a different error. Or should I have, I don't know. I will see. Later we will have more detailed errors, more structured anyway. Now we just have this span and message. Exception error is error. Print exception. Register error. I never returned functions inside errors in Rust. No. It's because like, so this over here is so like usually you just do a string here maybe, but I do a formatter into unit here because I have the colored stuff, right? I'm coloring like the pens and like some other things. So depending, so like sometimes the color are there, sometimes not. If I just store a string, then I will lose this information basically, yeah. But I will do it more structured anyway, like you would do in Rust. I feel like this is not the correct way. I should not be exiting in the printers, right? That's what I'm doing though. For now. Unbound constructor compiler error. How do I make it bound? How do I make it bound? Is it possible? Like I cannot just import, so like it's not in this module. I want to re-export a constructor. I think it's not possible in OCaml. Can I re-export constructors of a type of a constructors from one module to another? OCaml? No. Only values constructor not first class. What you can do, you can alias the type and open to expose the constructors, but that leaks everything. Yeah. Want to export constructors cleanly. Module A is A. Just expose the original module. So this means that the error should be in its own module. Why doesn't the camel just have like the use? Like I just want the same. So in Rust you just say like pub use module thing, right? Why cannot we have that? I guess I just have a module called error here. It's fine, and I just make this go into the module error. It's fine. Right? And then the cast compiler will just say that I want to include error here, maybe. And that's fine. So we only leak this stuff. Okay, but then this is not actually being used anywhere, right? So I want to find in folder compiler, I want to find fail. So there is a bunch of fails, right? Like apply must be an expression. We should instead say error, right? All of these. Unexpected arg. No, this one is fine, maybe. Handler, apply. Yeah, this should definitely be an error. Span. Just like in the Just say control replace in the compiler. No. Span. No, I want to replace fail space and that with span that. Okay. I guess I can just click this dismiss. All of these I want to replace. All of these I want to replace. I have span there. Yep. I just replace all of these. What's that? We have find binding from span. Would not find in scope. Yes. But this should be never mind. Number cannot be assignee. That's fine. That's fine. That's fine. That's fine. It's fine. To do compile syntax rule. To do. I think this is also fine. We're just going to see that the span is not always in the scope, right? So this span, for example, when I'm trying to find a binding in a scope, this is the span where I'm trying to find it. So this is just from here. Okay, and then also I need to obviously, I guess, open error everywhere, and then we have a function error. Just go to parser. This. Just going to copy paste that. Okay, core syntax. We are going to also open error. So constructors are not first class in a functional language, even though constructors are functions. No, constructors are not functions in OCaml. That's the thing. They are not functions. Constructors are functions in Rust. I think constructors are functions in Haskell, but in OCaml they are not. OCaml doesn't have, like, you can like I have been complaining about it earlier too, right? Over here, right? You see, I have a constructor and this is the argument. I cannot just say pass this as an argument over here, because this is being parsed as a constructor without an argument, you know? That's an issue. In fact, like, if we talk about the my language cast, I did have a separate syntax for the constructors too. There were reasons for that. Sometimes you do want to have like a constructor as a function, but like there are constructors with argument and constructors without argument, and there is like this like ambiguity sometimes. In standard ML constructors, create a new value of a given data type. A function returns a value of a given data type. Yes, but what's the difference? Like a function can create something inside of it. So like again, Rust treats type constructors as separate, as normal functions. I don't know about Haskell. Haskell Playground. Let me see. Yeah, I have print high. Foldable data foo is foo int, right? Can I say let Is it a let in? Yes, I probably is. Let foo be foo $123. Can we do a dollar here? In doesn't work. Hold on. That's bad. Haskell let in. I forgot about the syntax. Let this. Oh, I'm inside the do notation. I don't need an in, right? Yeah. I think it's only outside of the do notation there where I need it. So yeah, so see, like in Haskell, this is basically a function. Foo is a function, like because the dollar, right, is that. So I can say that foo constructor is int into foo is equal to foo, right? I can do that, right? But I cannot do that in OCaml. I cannot. I can export a separate function which acts like a constructor. All right, I'll need to add soon. Span. In this case is spans. Make binary operator to do. Span. Or syntax. No, this one's actually, I will just keep fail. Okay. It looks like it is compiled. So maybe we can see the thing already here. Oh, look at this. Cannot find in64 in scope. It works. We have the error. Is it shown like over here too? Oh, there is no core syntax. Okay, hold on. Now I have the errors in all of my cast files. There's no syntax for use yet. There is no in64. Now I have too many errors. There is a to-do over here in the cast compiler. Line 96 too. Okay, that's fine. Although probably I don't want this to be all red. Can you disable the diagnostics in VS Code temporarily? If I do a string, then it's all fine. Okay, nice, cool. Cool. Yeah, you know what? We have some diagnostics. It's nice. Compiler diagnostics. I'm just going to end here. Yeah. I think I will, I don't know. I'll think about it. There's so many things that I can go into and like choosing what to implement first. It's difficult, but I think I should like at least get the concept of the place expressions immediately. And also I started the context, right? Like we have this warning where the context is not used, right? I have parsed the context and I wanted to have the inference for context. It's actually still is in my stash, but maybe I will just, yeah, maybe like, can I even pop it? Stash pop. I guess I can, right? So I was trying to figure out how the row polymorphism, not row polymorphism, how the inference for like row variables should work. Yeah, a little weird. I'm too lazy to read like the papers fully. I can keep the old algorithm, which was like really slow, I think, that we had in the previous version. But it was not perfect. I'm not even sure that I can do that with the row polymorphism. Anyway. Um, there's a break happening here. Programming in assembly for Game Boy. It's been a while since I saw assembly.
I think in definition we have.
Thank you guys for watching. See you next time. Bye.